first steps to doing that is to understand the derivative. And by doing that, we're going to take two example functions of a derivative, and we're going to derive them. So we're going to do the derivative of y with respect to x of x squared, and we're going to get equals 2x, and that has a power rule. So what you do with that is you do x, and then you move this 2 down to here, so then that's going to get you 2x. This 2, we're going to do 2 minus 1 to get our new power. That will equal 2x. And then we're going to take the same function with a plus 2, and then we're also going to get 2x. Do x, 2, drop it down, 2x, then you do 2 minus 1, that will go 1, 2x. And then this 2 will go to a 0. Okay, so the next step in taking the antiderivative is actually doing the integral. And so with this function, we're going to do the integral of 2x, and then that's going to equal x squared plus c. And this plus c is really important because that shows that your function can have a possible value in it, which correlates back to x squared plus 2. Okay, and how we're going to do that, we're going to take the function 2x to the n, raise it to the n plus 1, divide the function by the new n value, and then add plus c. Okay, so now we're going to take the integral or the antiderivative of x squared. And so what we do is we'll write out the function, make sure to notate the integral squiggle and then the dx. That's really important with tests. So what we're going to do is raise, we're going to go 2 plus 1, we're going to add the power but plus 1, and that will get us x to the 3. Then remember back down here, you divide the function by the new n value, and that's the new power value. So then you're going to go x to the 3 over 3 because you dropped it down, and then you got to make sure to add plus c. Now we're going to take the integral of 4t to the third minus 2t to the fourth dt. So what we can do is 4t to the third. We're going to start with this chunk first. So you add plus 1 to the power, and then that will get you 4t to the fourth, and then you divide it by the new power, 4t to the fourth over 4, and that simplifies to t to the fourth. And then we're going to take the second chunk, it's going to be negative 2t to the fourth, and make sure to keep this negative 2 so you get the right constant. So you raise this power by 1, you're going to get negative 2t to the fifth. So t to the fifth over 5. Now you add t to the fourth plus negative 2t to the fifth over 5. We get plus c. So now we're going to take the antiderivative. Now we're going to take the antiderivative of this function right here. Okay, 25x to the fourth. So then we're going to raise the power by 1. So it'll be 25x to the fifth. And then you got to divide the new power with the original function. So you're going to go x to the fifth over 5. And that's going to simplify to 5x to the fifth. It's your first part. Now we're going to do negative 3x squared. And we're going to raise the power by 1, negative 3x to the third. Then we divide this new one by the new raised power. So we're going to get negative 3 to the third over 3. And we'll get negative x to the third simplified. Now you go 2x, raise the power by 1, 2x squared. Then you divide this by the new raised power. So then you'll get 2x squared over 2. We'll go x squared. You raise this by 1, so it will be negative 4x. We're going to add them all together. So 5x to the fifth minus x to the third plus x squared minus 4x plus z. When you feel like it.
All right, so for our review on our antiderivatives, step 1, raise function to the n plus 1. Step 2, divide by newly raised power. Step 3, don't forget your c. Step 4, take each part of function and do it individually.